Okay, we don't come back. From your jamb syllabus, now these things where you supposed to know. From separation techniques, jamb expect you say you supposed to know these separation techniques. So how we go know the separation technique what we supposed to do? But before we continue, subscribe to encourage us. So how we go know? You see, it depends whether you have a solid. If na solid dey inside liquid, or you want separate two liquid, or you want separate two solid, or you want separate two liquid wey no dey mixable, you understand? E mixable wey you no fit mix, or you want separate two liquid wey don mix. So now e go depend on wetin you want. I want jamb choose these 7 separation techniques. So these 7 separation techniques covers this all this thing. You understand? So we will check. For evaporation, evaporation dey work when you want separate a solute, which is something wey no be liquid, a solute from each solvent wey don already dissolve. So na where you go fit use evaporation. Evaporation, remember, for evaporation, we no dey interested for the liquid. We no wan collect the liquid. Na the solute wey we want. So we go just apply heat. You understand? We just apply heat, put the solute, put the solute and the solvent, solute and solvent. The solvent na the water, so the solute na the solid wey we wan collect. So you put your heat here. You go only do this thing if the solvent no be something wey dey burn fast, wey go fit catch fire. If na wetin dey catch fire, you no go apply heat direct. If not, you don finish yourself. So if na wetin go catch fire, you go use water bait. You go put water for here. You understand? Then put the heat on top of the water, below the water. You understand? Boil the water so that the heat, the steam wey dey come from the water go come dey do the heat work for here. You understand? So that the thing no go catch fire. But apart from that, if the thing no be something wey go fit burn, you go fit use this one. So let us check this. So make we imagine say no be something wey dey easily catch fire. Say na no be solute or liquid wey dey easily catch fire. So you apply the heat, put your gas here. So on top your, let's say, your tripod stand. Alright, so put your Bunsen burner. Forget all this one. So this one no be wetin you really want. Wetin they really want now, whether you go fit know the place. So if you put the water here, if you put the heat, wetin go happen be say the solvent, when it gets to the boiling point, you go dey boil, you go dey evaporate. So if it evaporates, you go leave only the solute inside. You go turn to steam. Alright, that's for that. So we will check for simple and fractional distillation. For distillation, it's still application of heat. But remember, say, for evaporation, we're not interested for the liquid. But for the distillation, we are interested in the liquid. You understand? And for evaporation, we dey get solute and liquid. But for distillation, we dey get two liquid. You understand? Two liquid wey we wan separate. So the two liquid might be mixable or we no fit mix am. You understand? E fit be say dem fit mix well, like alcohol and water. E fit come be say you no fit mix well. You understand? So, but the thing wetin dey work for distillation na the difference in boiling point. So if the difference in boiling point dey far from each other, then distillation can work. So now, how do we do this distillation? For distillation, we can't just put the heat, the two liquids there here, the two solvents, the two liquids there here mixed together can be mixable, it might not be mixable. So if you put your heat, wetin go happen be say anyone wey gets to the boiling point, e go lead to a condenser. So the thing, you go fit capture the thing through a condenser. You understand? So anyone wey reach the boiling point go leave this place, You understand? You go evaporate, go turn to steam, they pass through this place. So when it gets to this place, where you get a condenser, you go cool, can't drop back as liquid. You understand? So you go can't drop back as liquid. So you go get the liquid. But for fractional distillation, now when we get 3 or more liquids to separate. So you get like 2 or more liquid inside here. So we get difference in boiling point. So if you put the heat, as anyone will reach the boiling point, go leave this place. You understand? Drop. But don't forget, say the upper side, we get like, let me draw the full distance. So the upper part will they get something like this if the thing they leave. So if you put your thermometer here, this other side they cooler than this place. So this one will be hotter. So if the liquid evaporate, any of the liquid where they cool, where they equal to this temperature, where they go come out. You understand? Anyone where they equal to this temperature will come out. Then the hotter ones, when you get to this place, if you go up, you go condense back for the cooler one where they equal to this temperature will come out. That's how you will proceed. That's how you will repeat yourself until everything don't come out. So jamb will really ask you, say, for this column, which part they cooler? The upper side they cooler, and this side they hotter. You understand? So for fractional distillation, we introduce the fractional column. You understand? Or you can say fractionating column. So this that fractionating column now go help separate the thing very, very well. Most of the fractionating column they get beads where they inside, so that you go as the liquid they go, anyone where gets to the particular boiling point, you go just drop there, come out. So that is it. So for sublimation are just you just use to separate any solid which you directly convert to gas, like that, like camphor. If you get your camphor inside any substance, just heat them. Camphor go just sublime, turn to gas. If you capture it, you go return back to camphor. So that's by the way. So let's check for filtration. I've explained filtration in our last video. You can watch that. Okay. Alright, so for crystallization, we do get is a process of forming crystals. For example, when we get a solid inside a solvent, what you just do for crystallization? You heat it. If this is a solid inside a solvent, dissolve like a salt. So if you heat them very well, you heat them first so that some of the water molecule, if not water, some of the water molecule will evaporate. You understand? They go come out finish. So when they don't come out, only few will remain. Then allow the thing to cool. When you allow the thing to cool, crystals will be formed. When you allow the thing to cool, crystals will form. If crystals no go form, you go scratch the inside of the container to induce crystal formation. If you scratch the inside of the container, you start something that they call nucleation. Nucleation, which is the formation, the gathering of small particles. You understand? If those particles don't gather to form seeds, so nucleation will start. So allow the thing to cool, crystals will begin to form. If the crystals don't form, scratch the inside, or you introduce similar crystals of what you want to get. You introduce them. You understand? Those ones we introduce go start as seeds to induce the formation of these crystals. You understand? Now what we call crystallization. Then for magnetization, that's when you get something we feel magnets inside and now solid separation. You understand? For magnet, now solid separation. But some people now, you don't say magnets do they work for water. So if you get iron pieces inside water, the thing settle down, just put the magnet inside the water, you go drown. So that is it. So decantation, now just when you want to separate two liquids we get different density. You understand? Like for example, aqueous and organic phase. The aqueous phase usually they heavier because you get higher density, so you go settle for that. So you go just decant am small small. You understand? Or you open the bottom, collect am from that side. That's decantation. I forgot to add precipitation. Jamb also one may use am. This is precipitation. The formation of precipitates. So this one they work when you get two solids, when you get two liquids wey get different solubility pertaining one particular solid. For example, let me give you example. Sugar go fit dissolve inside water, but sugar no fit dissolve inside kerosene. E no fit dissolve inside kerosene. So sugar no go fit dissolve inside kerosene, but it can dissolve in water, but it cannot dissolve in kerosene. So if you have sugar dissolved in water and you want to take it out, so what you do is to introduce the liquid where sugar no go fit dissolve inside. For example, kerosene. If you introduce kerosene, okay, kerosene no go work. Kerosene no go work because the kerosene and water no dey mix together. Kerosene and water does not mix. But let's just take okay, let me give another example. This one to clean. Let me give another example. Example of precipitation, where precipitation dey work. If you have this iron, this is iron 2 tetraozo sulfate 6. This iron 2 tetraosulfate 6. This iron 2 tetraosulfate 6, they dissolve in water, but you no fit dissolve inside alcohol. You understand? So if you get this dissolved in water and you want it back, what you go just do is say you go just add alcohol where the thing no go dissolve inside. So this thing dissolve in water but does not dissolve in alcohol. So if you want to get it from you want to make it from precipitate, mixer, put am as it don dissolve inside water, just add alcohol. You know alcohol and water go fit dissolve, go fit mix well. So shake am make the thing mix. After some time, you go see tiny particles wey dey form. Tiny particles of this wey dey form, you go dey come out as precipitate. You go dey form solid inside. That precipitation na just the sudden formation of solid from what has been dissolved before. You go just dey form solid. So you don see am. So this thing now, if you mix am inside water, you want make I get am, you just add alcohol, shake am. Alcohol go come mix well with the water. Then with time, this thing go begin dey form precipitate. So we go proceed. We go finish jamb syllabus, finish correct syllabus, finish all the chemistry questions with PG. Thank you. Follow.